This is 3-6 day 2 lesson. We were talking about systems, and I just want to say that systems of inequalities may contain more than two inequalities, and they would be solved in the same way. We're going to classify our systems as infinitely many or no solution. So the first thing we're going to do is use the method of elimination, because in multiplying we'll be able to use small numbers. So let's take the first equation and the third equation if you notice, we can eliminate the y's right away by adding the two equations. Now we need to do the same thing, eliminate y's from two other equations. So I'm going to take equation 1 and equation 2. I'm going to multiply equation 2 by 2. And this should be an x up here. I can once again eliminate the y's. Now I have two equations and two variables. I'm going to write those, and if you take notice, and there's another mistake when I added these together. I don't know why I thought there was a negative up there. Should be a 12. And that's a false statement. And since that's a false statement, this is now inconsistent with no solution. Okay, we're going to do the next one together also. We can take, I'm going to write equation 1, 2, 3. I take equation 1. And equation 2. Multiply equation 2 by a negative 1. Can add those together. And then I'm going to take equation 1 and equation 3 and multiply equation 1 by 3. I'm just going to write over top of this. So it turns that into a 9, a 3, a 6, a 12. Add those together. And you end up with 0. So that didn't work out very well. So I'm going to try equation 2 and equation 3. Once again, I want to eliminate the y's. So I'm going to multiply equation 2 by 3. Leave equation 3 the same. Add those. And now I can take those two equations. I'm going to multiply the first one by a 3. Add those together. And you get a true statement this time. So this would be consistent and infinitely many solutions. Okay, and the last one here, take equation 1. And I want a y minus, or I want a y and a z, so I'm going to eliminate the x's, multiply the second by a negative. Add them together. And then take equation 1, multiply it by a negative 3, or I'm sorry, equation 3, multiply by a negative 3. Add those together. I get 0 equals 2, which is false. So this is inconsistent with no solution. And we have just the closing. Explain the different ways you could go about finding the solution of the system of equations below. Could basically eliminate the z in equations 1 and 2. So let's go ahead and do that. In order to eliminate the z, I have to multiply equation 1 by 5. Having issues adding. Issues adding, multiplying up here. See, even I make terrible mistakes. And then with this, we use substitution. and substitute in for x. And then substitute again in our x equals y plus 6. And then substitute those in equation 2, which we would have 2 plus 2 times negative 4 minus 5z equals negative 1, and solve. It's negative 6, add 6, you get 5. So z equals negative 1. So our solution would be, I'm going to write it up here, 2, negative 4, negative 1. And that concludes lesson 3-6.